Today I'm going to teach you about polynomial division. Now, this is the very basic level of polynomial division. It's before we do any factoring. The goal is that after you finish this video, you're going to be able to divide multi-term polynomials by monomials. When simplifying quotients, those are your division problems, containing numbers and variables, I want you to remember these two things. You're always going to simplify the coefficients and subtract the exponents. So in this case right here, 24 and 8 actually simplify to just a 3. And then I'm going to subtract my exponents. 5 minus 3 is 2. And this becomes this right here. That's key to what we're doing today. I'm going to start with some simple ones and then just keep getting harder each time I go to a new problem. One thing you need to know is that when I have a plus sign here in the middle of my numerator, I'm actually going to separate this into two problems. 6x squared divided by 3 and 9x divided by 3. And I'm just going to simplify each one of these quotients. 6 divided by 3 is a 2, and the x squared stays the same. And then 9 divided by 3 is a 3, and the x stays the same. And there you go. That is my final answer. This time you'll notice that I added an x to the denominator. Not a big deal. Let's go ahead and make this into two different problems. So my suggestion is when you are working on these problems, make sure you have a piece of paper or a whiteboard or something to work them out on. All right, here we go. I'm going to start with the 8 divided by 4. That's just a 2. And then what is the exponent on that x in the bottom? Yeah, just a 1. And so 3 minus 1 is 2. There we go. And the next one, 12 divided by 4 is a 3. And then x2 minus x1, just an x. There you go. All right, this is basically the same thing, except I have a negative sign instead of a plus sign. And I have more x's on the bottom, but still I'm doing the exact same thing. I'm splitting this up. And then I'm just going to put a minus there instead of a plus. Alrighty, the first one, 6 divided by 2 is a 3. And then remember, I'm subtracting my exponents. 6 minus 3 is 3. And then 8 divided by 2 is a 4. The x to the power of 3's cancel each other out, and I'm done. What do you think? Easy? The only reason this one is harder maybe is just because 13 and 7 aren't going to be divisible with each other. So I'm just going to separate these right here. And this one. All right, here we go. 13 and 7, they're as simplified as I can get. So I'm going to leave them as a fraction. And then I have this 5 minus 2, which is 3. And that would be in the numerator. And then here, 14 divided by 7 is a 2. 3 w's divided by 2 w's is just going to give me 1. And there's my answer. So basically, exactly the same thing I did. It's just that I had to leave a fraction for my first term. All right, taking this up a notch is just because my denominator is negative, and that is it. If I don't even have a coefficient bigger than -1 there. So I'm going to do this, separate them all. Remember that plus sign becomes a positive sign with that 3, so I'm actually going to put it under the line there, and that's -4y3. I'm going to keep that right there. All right, here we go. 5 divided by -1, just going to be a -5. And then 7 minus 2 is 5. All right, 3 divided by a -1 is a -3. 5 minus 2 is a 3 for my exponent. And then -4 divided by -1 is a +4. And then 3 minus 2 is just a 1. And there you go. All right, I'd love to know how you're feeling about this. Okay, taking it up another notch, and that's just because I've added more than one type of letter. So let me go ahead and spread it out just like I've been doing for all the rest. All right, here we go. Let's take this slow. -32 divided by -4 is going to give me a +8. But I want you to look here. I have 2 x's on the top and 5 on the bottom. I got more on the bottom, which means my x's are going to land right here to x to the power of 3. And then my y's, I do have more on top, so that'll be a y. 5 minus 2 is a 3. All right, next one. Can I simplify 27 and 4? Nope. And it looks like it's going to be negative, so I'm going to say minus. And I'm going to put the 27 here and the 4 here. All right, let's look at the rest of it. x7 minus 5 is 2, and I have more on the top. And then y5 minus y2 is y3. And there you go. Looks a little ugly, but that is the final answer. Up another notch. What is this madness? Well, literally, it's the same thing you've been doing, except they put the divided by over there. But if I sit here and I go 2u to the 5, x to the 3, doesn't that look the same? Yeah. So let's go ahead and spread it out. Okay. Are you ready? Here we go. Let's do the first one. 14 divided by 2 is a 7. And everything else cancels out. All right, next one. 18 divided by 2 is a 9. And then I have 6 minus 5 is 1u. 4 minus 3 is 1x. All right, minus, and I'm going to say negative 6 divided by 2 is a 3. And I'm also going to tell you, be careful because I'm going to have an x on the bottom. So I need to make this a fraction. Okay, so here we go. U6 and 5 is just 1u. And then 2x's on top, 3x's on bottom. I have more x's on bottom. So 3 minus 2 is a 1. And there we go. And that is our final answer. Well, have I taken it up a notch again? No, not really. This time something is a little bit different. I actually just have a multiplication problem on top and on bottom. I don't have a plus sign between two binomials. So what I'm going to do is I'm going to show you some things here. First of all, do you notice that I have this, and they're the exact same thing? So I can actually cancel those out because anything divided by itself is just a 1. So I'm going to go ahead and cancel that out, cancel that out. I'm going to go here. Now, the deal is before I leave the other two, and I can't separate them. I can't cancel out the 7s or anything because they're within a binomial with another term. So they're stuck being the way they are. But look at the 4 and the 32. Can I simplify them? Sure enough. So 4 and 32, if that was a fraction, would become 1/8. I'm not going to put the 1 on top, and because I don't have anything multiplying times 2u plus 7, I'm just going to keep it like this without parentheses. Now the bottom, I do need to make that still a multiplication problem, so I'll put 8 and 3u plus 7. Now, is that as simplified as it could be? I could multiply those out and make the bottom 24u plus 56, but I'm just going to keep it like this for now. Well, here we go. Last problem. How brave are you? Well, if you're brave enough, go ahead and stop this video, try this, then come back and see how close you were to the right answer. Maybe you would get the right answer. That'd be awesome. Okay, are you back? Here we go. Well, the first thing I'm going to do is I'm going to look at that 15 and 18 and realize that they are both multiples of 9. So here we go. 45 divided by 9 is a 5, and 18 divided by 9 is a 2. So I'll go ahead and do my division line there. And I'll say 5 and 2. All right, next thing. I want you to notice that I have two binomials that look very much alike. This 2x minus 7 and this 2x minus 7. And the top one has an exponent of 3, and the bottom has an exponent of what? Yeah, a 1. All right, and so basically I'm just going to treat them like I treated my x's and my y's in the earlier one. I'm going to say 3 minus 1 is a 2. Since I have more on top, I'm going to put it right here. So 2x minus 7 to the power of 2. And then I'm also going to notice that I have the same binomial here and here. And let's see, the bottom one is to the power of 2. The top one is to the power of what? Yep, a 1. And so I have more on the bottom. 2 minus 1 is 1, which means I just have one of these here. And I'm going to call that a day. Here we go. All right. How'd you do? Now it's your turn to go and have some fun playing around with these.